Welcome to this deep dive on baseline evaluation for large language models, presented by Dr. Microlearning. In this session, we will outline practical methods to compare models, establish evaluation anchors, and connect metrics to real user outcomes. Over the next slides, I will guide you from high-level frameworks down to concrete tools and operational practices that drive reliable, repeatable model assessments. This slide shows a pragmatic way to blend public benchmarks with a domain-specific gold dataset to get the best of both worlds. Public benchmarks give standardized metrics and broad coverage, while a curated gold set captures real user queries and nuance. The integrated strategy combines them to produce comparable rankings that remain relevant to your domain and ultimately improve user satisfaction. When we use subject exams like MMLU, MMLU Pro, or Helm, we gain wide coverage of world knowledge and can flag memory gaps in models, but multiple choice formats miss free-form reasoning and suffer contamination risks. Treat high scores as a necessary baseline signal, not the full story, and complement these exams with more targeted, task-specific evaluations to validate deeper capabilities. To quantify and mitigate risks, we layer automated tools that test truthfulness, detect toxic output, and provide fine-tuned verifiers for specific criteria. Combining specialized detectors with LLMs as judges allows scalable review while exposing bias and misinformation. This automated toolbox helps assess deployment, readiness, and guides safety improvements before real-world release, keeping user harm and hallucination in check. For functional correctness, we rely on benchmarks like Human Evil and MBPP+, pass at K-metrics to estimate success probability across attempts. These core measures correlate well with developer productivity on real coding tasks, but robustness needs supplements such as complexity analysis for maintainability and security audits to uncover execution vulnerabilities. That combination produces more trustworthy, production-ready assessments. Evaluation should look beyond surface, overlap to capture meaning and final answer fidelity. Lexical metrics like BLEU and Rouge are useful for translation-style tasks, while BERT score captures paraphrase quality and semantic alignment. For math or logic queries, verification-style extractors that compare final answers and balance automation cost with human judgment offer a practical path to accurate, defensible scoring. To scale evaluations and reduce stochastic noise, we can use scalable human-like assessors and self-consistency ensembles. AI evaluators mimic human judgment at high volume, providing automated scoring and comparative leaderboards, while ensemble sampling with majority aggregation reduces random response variation and tightens confidence intervals. Together, these techniques increase throughput without sacrificing reliability or interpretability. A living benchmark lifecycle keeps tests relevant by combining synthetic prompt generation with injected real user queries, annotated edge cases, version control, and scheduled audits. This living anchor serves as a regression baseline that both tracks offline metric improvements and links evaluation gains to live user happiness, ensuring that benchmark changes reflect real improvements rather than transient artifacts. A robust process flow starts by fixing temperature sweeps to control stochasticity, then running end-shot evaluations to probe few-shot learning, and computing mean scores and variance to quantify dispersion. Sensitivity analysis then separates expected system noise from apparent deltas that may indicate architectural differences, helping stakeholders interpret when score shifts require deeper investigation or adjust statistical fluctuation. Treat model evaluation as an ongoing regression test rather than a one-time activity by combining pre-deployment benchmarking with lightweight live sampling and drift detection in production, plus periodic full-suite reruns. This continuous framework guards against model decay, data contamination, and emerging failure modes, so teams can respond quickly when performance or safety signals drift over time. Embedding evaluation into MLOps means building multi-metric dashboards for real-time performance tracking, running adversarial red team sprints to surface vulnerabilities, and keeping documented decision logs for traceability and compliance. By creating a shared ritual of baseline comparison between product and research, Teams converge on transparent, evidence-based model choices and keep evaluation tightly integrated with delivery and governance.